In this video, I am going to set up this word problem, but I am not going to solve it. So the first thing that you want to do with any word problem is define your variables. What is it that you're looking for? What are your unknowns? And let's assign them a variable. Well, I like to go to the very last line. What is the optimal number of bags for each brand that should be mixed? What is the optimal cost? So we have brands. So we have brand X and we have brand Y. Well, that makes it kind of easy. I'm going to let X be equal to the number of bags of brand X. And I am going to let Y be equal to the number of bags of brand Y. So what else do we know? We want to find the optimal cost. Well, when we're dealing with cost, that usually means the minimum cost. Remember, optimal is a term that means either maximal or minimal, maximum or minimum. So with cost, we're usually looking for a minimum cost. And so I'm going to let C be cost. And up here we know that brand X costs $30 per bag. So if we take 30 times the number of bags of brand X, we would have the cost of brand X. Brand Y, $25 per bag. So we would take 25 times Y. And that would be our objective function. The next thing that we need to do is find our constraints. And so that's what we're going to be looking for here. Brand X contains 2 units of nutritional element A, 2 units of element B, and 2 units of element C. So the makeup of these bags of brand X and Y are constrained by the elements A, B, and C. So I am going to say, okay, so we have A, B, and C. Those are the nutritional elements. And so brand X contains 2 units of element A. So if we take 2 units of element A times the number of bags of X. 2 units of element B, so 2 times the number of bags of X. And 2 units of C, so 2X there. Brand Y contains 1 unit of nutritional element A, so that would be 1 times the number of bags, Y. 9 units of element B, so 9 times Y. And 3 units of element C. And of course, we want to add these together. Finally, the minimum requirements for nutrients A, B, and C are 12 units, 36 units, and 24. So if those numbers are the minimum requirements, that means the nutrients can be that number, 12, 36, 24, or greater than. So we would say greater than 12, greater than or equal to 36, greater than or equal to 24. And so those are my constraints. And we really don't need this anymore. So these would be my subject to those constraints. So in this section, we're solving these graphically. So at this point in time, you would graph your inequalities and you would solve it like we've learned how to solve linear programming problems graphically. All right, I hope this helps.